Hey everyone, it's Mark here. In this video, I'm going to show you how to do a rolling regression with time series data in Stata. Now, it turns out this is actually a little bit easier than you might initially think it would be. So to do this, I'm going to walk you through a regression here using particular data within Stata. Now, the data that I have is in fact a time series data of stock returns, and in particular, a time series data for Tesla stock returns. So I'm going to import that data, and then we can see what we'll do here. So I've imported the data here. Now we can just browse it and see what the data looks like. So we can see how we'd start doing this. So in this data, I have some firm identifiers. So perm nodes, tickers, etc., etc. That's not really that relevant to us. I also have a date variable, which is going to be relevant in terms of running a time series regression. And then the most relevant thing here is the return. Now, notably here, the return series here starts in my second row as opposed to my first row here. You could obviously just drop this first row if you're only interested in returns. In addition to this, we also have some market indexes. The market indexes here are VW, RET, and EW, RET. VW is value weighted, EW is equally weighted. Hence the names VW and EW. I also have included an observation number, and I've included some rolling averages and standard deviations. What we are going to be interested in at the moment, though, is going to be calculating a rolling regression and getting some rolling regression outputs. This is obviously relevant if you want to calculate the firm's beta over time, because say, for example, in this case, you wanted to calculate the regression beta, so you can then calculate what the firm's sensitivity and responsiveness is to the market index. You could look at how that would fluctuate over time by doing a rolling regression. You could do this in many other applications as well. This is just one of many applications for a rolling regression, and just for illustration purposes. So that we've imported our data. The first thing we need to do is we need to time set our data. We would do this using the tset command. So that would be tsset. Notably here, tsset. Then you need to type in the particular time series variable. Now this could be a date, but it could also just be a number. For example, if you have an observation number going from 1, 2, 3, etc., you could tset by that observation number. I'll just tset by date here, but obviously I could do it by observation number as well. So I've now time set the data. The next thing I need to do is I need to use the rolling regression command. So the way this works is you go rolling as like the first base command. Then the next thing you need to type in is you need to tell it, well, what variables or what outputs do I want from my regression? So for example, say I want the regression beta, I do _b. Say I want the regression standard error, I do _se. Say I want the regression R squared. Well, this one is a little bit less obvious, but it is intuitive. The reason it's intuitive is it will come down to what a regression would look like. So we would go here, R2. R2 here is just like a variable name I'm creating. R2 is equal to, then E, and then R2. What this is basically telling Stata is after a regression, any regression, it will produce an R squared from the regression. The R squared in Stata is stored as R2. That's like his little coding name here. And then E is effectively where it's going to be stored after the regression. So basically what we're telling Stata is when you've run a regression, extract that stored R squared. Extracting the stored R squared is the ER2 bit. And then the R2 here is the name we're assigning to it. So that's what we've got to begin with. But we haven't so far told Stata anything else about what the regression is going to be. So what we next need to do is we need to tell it what window we want it to be a rolling regression over. And then we need to tell Stata what we want the regression to look like. So we'd go here, window, and then however many days. So let's go with 200. Again, it could be 250, it could be 1,000, it could be 10, hypothetically. You wouldn't do it for 10 days, but you could in theory. So you've got your window. Now, the next thing you need to do is tell Stata, what exactly is my regression going to be? So here, we put colon, and then we need to put in the regression specification. So let's go like with a really, really basic one. So I'll go with red, and then I'll go PRC, or I could go RET, sorry, which is the stock return variable. And then that's going to be a function of the equally weighted returns. So EW, RET D. Now here I've got the return stored as RET and the price stored as PRC. Obviously, if you did a regression of price onto the market index, that will give you a really weird result. In any case, That's what my rolling regression syntax is. Now, you could make this a little bit more complex. So, for example, say you're really interested in the standard errors, and you're pretty sure there might be heteroscedasticity. You can use robust standard errors as well. So I'd then go comma, then robust, just to include that. Or you could cluster potentially. So we do that rolling regression, and I'll click enter. It will now start the rolling regression. The rolling regression can take a while. So you will end up seeing its progress here. Now, you'll see how these dots are being produced in Stata. You could tell Stata to not produce those dots by using a no dots option. Now, that may or may not be beneficial to you. If you really want your output to not be very cluttered for the purpose of a log file or whatever, then you could obviously get those dots suppressed. However, in general terms, it's going to be better to report them, just so that you can keep track of what is going on. Now, while we're waiting for this regression to finish, it is worth digressing a little bit and discussing what else could we get from our rolling regression. What other outputs could we get? Because so far I've got an R2 or R squared, sorry. But could I get anything else? What about the F statistic? What about the adjusted R squared? What about any number of other outputs in case you happen to be interested in them? And for some applications, you might very well be interested in. I'll discuss that in just 1 second. So now our regressions are finished. We've got over 3,600 of them. Of course, we had quite a long time series. Now, what you'll notice here is over in the data portion, the variables portion, you'll notice that my data set has now changed. And you'll see this if I go to browse as well. So if I go to browse, what you'll notice is I now have a data set here. Now, in this new data set, I have a start date. That's the start date of the regression. The end date is the end date of the regression. I have the betas. So this first beta, that's the regression beta of my independent variable, my dependent variable onto my independent variable. So here, the Tesla stock return onto the equally weighted market index return. So the bog standard beta. This beta here is the constant. In a single index model, this would be the alpha. And in the single index model, this would simply be the beta of the stock. I also have the standard errors in case I happen to want those. Here I've just reported them for the sake of completeness. And I have the R squared. Now the R squared here is a bit mediocre. It's not brilliant. It is very small to begin with. Possibly because Tesla is quite a nascent company at the beginning of the time series. So maybe there's just not enough of a track record. Because oftentimes for newly listed companies, they behave slightly differently from the rest of the market. But if we go further forward, you'll see further down, the market index starts to explain more and more of what's happening. Again, it does fluctuate quite a bit, however. So that's effectively what our output is looking like. So the question is, what would we do with this? Well, that really depends on what you're actually interested in. Maybe you do want to see your rolling betas and merge your rolling betas in to your normal data set. So for us to do this, we need to save our data set and then merge it back in. Now, that's something that you could potentially do if you were interested in doing it. Now, it is simply a matter of merging data together to be completely clear here. So we can do that. Here you have to go capture save, and then you'd save it as a new data set. So we can go capture save, and then I'll just go with this output. It doesn't really matter what you call it, and then replace. And this will save it. So what I can then do is I can bring this into the old data set. Now I just noticed that I forgot to sort this data. So what I need to do here is I need to A, create a new variable that I can merge by, and then B, sort it for that merge to actually occur. So what you'll notice here is the end date is the end of the regression. So I'm going to want to merge it in by the end date. The reason I say that is I'm going to want to basically be able to merge this in so that I'm able to line things up. So I have a historical beta regression. So I'm going to rename end as date. The reason for that is now I can merge by date because date was the variable in my old file. And then I'm going to drop start just so that I can avoid any confusion. Then I'm going to sort by date so that I'm going to be able to merge by it. And then I'm going to once again save it as my output data. So I'm going to be able to merge. Now, the next thing I need to do is I need to bring in my old data set. So let's reload my old data set. Then I'm going to sort by date. And this is going to enable me to merge. Then I'm going to go merge. And then after I've done merge, I'm going to need to be able to merge effectively by date. So I'll go merge date, then using output data. And then this is going to tell Stata to merge in this data that I had before. So that's effectively what I'm going to end up with. I've merged in my betas into my normal data set, and I'm going to be able to analyze it in any way that I wanted to beforehand. Now, you might recall that I mentioned that I'd requested R squared to be reported in my rolling regression. What if I want other things to be reported? How would I do this? Well, to see this, I'll just run a normal regression. I'll regress the return onto the market index return. So I've run a normal regression. Now, say I wanted, for the sake of argument, my F statistic reported, or whatever. To see any of these things, I go eReturn, and then list. This will list all of the things that the regression is calculating and that are stored that I'm going to be able to obtain. So here, for example, I can obtain my adjusted R squared, plain vanilla R squared, whatever I want, I can obtain from this regression. And this is going to enable me to bring that into my rolling regression output if I wanted to do so. Again, this might be useful for particular applications. So that's basically how you'd go about doing a rolling regression in Stata. Now, I should remark as an aside that you would be able to do this manually if you wanted to do so. For some applications, it might be beneficial for you to manually calculate the regression beta. This is mainly tenable when you have a simple linear regression, a regression with effectively just one regressor. As soon as you have multiple regressors, that might become a little bit less preferable. However, with one regressor, it is relatively straightforward for you to be able to calculate that and for you to be able to bring in a beta that you have manually calculated into your regression. So it is something that you would be able to do if you wanted to do so. All right, so that's how you'd go about getting a rolling regression Stata. I hope that has given you a bit of an idea about how to do this. It might initially appear slightly intimidating for how to do it, but overall, once you get used to the syntax and the approach to going out and doing it, it isn't actually as painful or as problematic as it might appear to be. So I hope you found this video useful, or at least somewhat interesting, and I hope that it helps you with your data analysis. And I also hope to see you for future videos as well. So thanks so much for tuning in, and like I said, I hope to see you again. Bye.